This is the first part of the review for our test coming up on Wednesday and Thursday on intercept form of quadratics, factoring, and cubic functions. So what we're going to do is we're going to look at a review, and I want to thank Mr. Chestnut for giving me a copy of these questions and for making these questions. So this is his test review. So we're going to go ahead and start working these questions one at a time. The first section, this video is going to be in pieces. This is part one, and this is using intercept form. So the first thing we're going to look at is how to identify the x-intercepts from an equation in intercept form. Now what x-intercepts are is when we have a quadratic function, which is our parabola can look one of 3 or 4 ways. This, for example, this parabola has 2 roots because it intersects the x-axis twice. So it's got 2 x-intercepts. This is your x-axis. This particular parabola here has 1 x-intercept because it only intersects the x-axis one time. And then we also have those parabolas, like this one, that have no x-intercepts, or as we categorize them as imaginary roots. So the root is the same thing as the x-intercept. The x-intercepts are also called the roots, or the x-intercepts, or the zeros. And we call them zeros because every point on the x-axis has a y-coordinate of 0. So every one of these roots has a y-coordinate of 0. So when we come over and we look at these equations that are in intercept form and we want to find the roots of the equation, what we're going to do is we're going to set the equation itself equal to 0. So I'm going to take the equation and I'm going to set it equal to 0. So I'm going to replace the y with 0 because I'm looking for all values of x where the y value is 0, and that is our x-intercepts. Once we've done this, we know we've got 3 factors here. We have -2, x minus 5, and x plus 7. Those are all factors, which means they're all multiplied. So in order for us to get 0 as our product, as our answer, any one of these 3 could equal 0, because 0 times anything is 0. Well, -2 can't equal 0, because -2 is -2, so we don't have to worry about this constant. So let's look at our 2 factors. I have x minus 5, and I have x plus 7. So we want to see what makes x minus 5 and x plus 7 equal 0. So what I'm going to do is I'm going to take each of these factors, x minus 5, and I'm going to set it equal to 0. So in order for x minus 5 to equal 0, x has to be positive 5. So there's one of our roots. The next one is going to be x plus 7. So I'm going to take x plus 7 and set that equal to 0. And when I solve this one, x must equal -7. So my final answer to number 1 is my 2 roots are x equals 5 and -7. And if we were to write these properly, that would be 5, 0, and -7, 0. Those are our 2 roots. So let's look at number 2. Now we look at number 2, we have the same thing. We're going to set the equation equal to 0. And don't worry about the constant that's in front, the 3, because we can't do anything with that. So now we have 2 factors, just like we do with the first one, except now our factors are x. So what makes x equal 0? Well, that one's easy. X is 0. Then the next one is we got to make x minus 6 equal to 0. So I'm going to solve that. I'm going to add 6 to both sides, so x also has to equal 6. So there are our 2 roots, 0 and 6. So the way we write this correctly is 0, 0, and 6, 0. So that's how we find the roots. So let's look at our third example. And here comes our third example. We have 0 equals x plus 2 times x minus 4. So we're looking for the 2 values that will make these factors 0. So what would make x plus 2 equal 0? Well, let's solve it out, and x would equal -2. The other option is to make x minus 4 the 0 term. So I'm going to add 4 to both sides. So x equals 4. So those are my two roots for this example. So therefore, I have -2, 0, and 4, 0. And that is how we determine the roots of a quadratic using intercept form. So let's move on to the next example. Identify the axis of symmetry from an equation in intercept form. Well, when you have an axis of symmetry for a quadratic, every quadratic has an axis of symmetry. So wherever that vertex is, that axis of symmetry is the vertical line that cuts it in half. It goes right through the center of the parabola and through the vertex. So how do we find this vertex? Well, whenever you're given an equation in intercept form, that tells you that you have two intercepts. So your parabola will look something like this, or it'll look something like this, where you have actually two intercepts. So in order for us to find the axis of symmetry, all we have to do is find the halfway point between our two intercepts. So the first thing we're going to do is I'm going to find my two intercepts. And from what we did up here, we know that our two intercepts are going to be +3 and -3. So I have 3 and -3. Those are my two intercepts. Number 5, my intercepts are going to be +5 and -7. You may have realized the pattern by now. It's always the opposite of what's inside. So the next one is going to be -1 for this factor and -7. So those are my intercepts. I didn't write them out in intercept form like I did at the top. But what do I do with these? Well, I know my axis of symmetry is going to be exactly halfway between these. So in order to solve this, what I'm going to do is I'm going to take my two roots, or my two intercepts, just like you average your grades. If you got 100 on a test and a 90 on a test and you want to know your average, you do 100 plus 90 divided by 2. We're doing the same thing here. 3 plus -3 divided by 2. So we get 0 over 2, which is 0. So 0, and this is x equals, by the way, because this is a vertical line, x equals 0 is your first axis of symmetry. That's for number 4. So on number 4, x equals 0 is going to be your vertical line. So it'll be through here. On the second one, we have 5 and -7. So x equals 5 plus -7 divided by 2. -7 plus 5 is -2, so I've got -2 over +2, which is -1. So the axis of symmetry for number 5 is x equals -1. Again, the axis of symmetry is halfway between your two roots. So my next one, I've got -1 and -7. So my axis of symmetry is going to be the average of these two, -1 plus -7 divided by 2. That's -8 over 2, which is -4. So the axis of symmetry for number 6 is x equals -4. And we write them this way because they are vertical lines. And vertical lines, by definition, have equations x equals. So that's how we identify the axis of symmetry. We take the average of the two roots. Okay, on the next section, as we move down here, now we're going to be identifying the vertex from an equation that's in intercept form. And as we looked at in the previous example, when you have a vertex, the vertex, if you look up here in this example, the vertex is always sitting on the axis of symmetry. This would be my vertex for this one, there's my axis of symmetry. This would be my vertex for this one, there's my axis of symmetry. So for the vertex, what I have to do is I have to do what we did in the previous example, which is take the two roots. This is when we're in intercept form. I'm going to take the two roots and I'm going to find the midway point. So I'll do that first. So let's look at number 7. Number 7, my two roots are -2 and +2. So I'm going to now find the average of those two. So I have -2 plus 2 divided by 2, and that gives me 0. And remember, that's x equals. So I know, since my vertex is on the axis of symmetry, that the x-coordinate of my vertex has to be 0. So for my vertex, I know the x-coordinate is 0. So how do I find the y-coordinate? Well, we go back and we plug into the equation. So I'm going to plug into the equation. I'm going to take 0 and I'm going to plug it in for x. So I have 3 times 0 plus 2 times 0 minus 2. And when I multiply that all out, I have 2 times negative 2, which is negative 4, times 3, which is negative 12. So my vertex for number 7 is at 0, negative 12. That's my first vertex. So let's look at number 8. Number 8, my two roots are positive 2 and positive 1. So I'm going to find the halfway point between those two. So x equals 2 plus 1. Remember, this is your axis of symmetry, divided by 2. So 2 plus 1 divided by 2 gives you 3 over 2, which is 1.5, or 1.5. So I know that my vertex is going to have an x-coordinate of 1.5. So to find my y-coordinate, I'm going to take that 1.5 and I'm going to plug it back into the equation. So I've got 1.5 minus 2 times 1.5 minus 1. And when I multiply that together, I get negative 0.5 here, and I get 0.5 here. And when I multiply those two together, I get negative 0.25. So the y-coordinate of my vertex is negative 0.25. And there's the vertex for my second one. For my third one, I have these roots right here. So my third one, I'm going to have roots of negative 3 and negative 7. So once again, I follow my pattern. I'm going to do, to find my axis of symmetry, I do negative 3 plus negative 7 divided by 2. It gives me negative 10 over 2, which is negative 5. So by definition, knowing my vertex is on the axis of symmetry, I know the x-coordinate of my vertex is negative 5. So to find the y-coordinate of my vertex, I'm going to take that negative 5 and I'm going to plug it back in to the equation. So I have negative 2 and then negative 5 plus 3 times negative 5 plus 7. And negative 5 plus 3 is negative 2. Negative 5 plus 7 is 2. So basically I have 2 times negative 2 times 2 by plugging in. So I'm going to get negative times a negative is a positive. That's positive 4 times 2 is 8. So the vertex for this one is at the coordinates negative 5, 8. So that is how you find the vertex from an equation in intercept form. So let's look at one more thing that has to do with intercept form. And we're going to identify the y-intercept. So we're going to identify the y-intercept from intercept form. And the way we do this is very simple. To identify the y-intercept is what you get when you multiply the equation out. So if I had standard form here, which is ax squared plus bx plus c, remember my y-intercept is my c value. But I'm not in standard form. So what's the shortcut to actually find out what this c value would be? And it's actually pretty simple. You're going to take the product of your a value times this constant times this constant, because that is going to be your final term when you distribute these all out. So here I've got 4 times 1 times negative 4, which would come out to negative 16. So negative 16 is my y-intercept for this particular example. And the way you would write that coordinates is x-coordinate 0, y-coordinate negative 16. So let's look at the next one. The next one we have negative 3 times 1 times negative 1. So I have negative 3 times 1 times negative 1. When I multiply those together, I have a negative and a negative, which makes a positive, times a positive. So the answer is going to be positive 3. So my y-intercept is at the x-coordinate 0, y-coordinate 3. And my last one, I've got my a value is 1 times 2 times 6. So 1 times 2 times 6 is 12. So that means that my y-intercept is at 0, 12. And that is how you find the y-intercept from intercept form.